Hello, Dragons. Today's lessons we're going to be moving from the linear parent, talking about their transformations up and down and steeper and flatter, and we're going to move over and basically do a similar thing with the quadratic. So just briefly a review. Remember, the linear parent is the equation y equals x. And we know that if we use function notation, that would be f of x equals x, where y is replaced by f of x. And so here's the picture. It goes through the origin. And remember, if y is equal to x, if x is negative 2, so is y. And if x is negative 1, so is y, and so on. So you can see that the ordered pairs are basically twins. 0, 0, 1, 1, 2, 2, 3, 3, etc. Crosses through quadrants 1 and 3. Now, it's called the parent because it is the most basic. The linear form of any line is y equals mx plus b. Well, in this case, what's my slope? My slope is up 1, right 1, up 1, right 1. Well, that rise over run is 1 over 1, which is 1. So my slope is 1, and my y-intercept is 0. Well, we don't need to write a 1 in front of any variable. It's just a variable. And we don't have to add 0 to anything as far as visually. So we just leave it off. And so that's how y equals mx plus b becomes our parent function. Now let's look at the quadratic. The quadratic parent is the equation y equals x squared. So we're going to square things. We're going to multiply numbers by itself. So if we multiply 0 by itself, 0 times 0 is 0. 1 times 1 is 1. 2 times itself is 4. And if we extend that, 3 times itself is 9. Well, let's do the same thing up here with the negatives. A negative times a negative is a positive. 1 times 1 is 1. A negative times a negative is still a positive. 2 times 2 is 4. So you notice my outputs of my parents, all of these guys are positive. So that's, you can see these points up here. There's 0, 0, 1, 1, 2, 2, 2, 2, that's, I'm thinking linear, 2, 4, and then 3, 9. Okay? Now, there's a whole bunch of different ways, different forms of this equation. There's standard form, there's point slope form. Let me just show you standard form real quick. This would be y equals ax squared plus bx plus c. Well, again, if it's a parent, just like with the line, we want the most basic. So if we want this to be basic, what we're going to do is we're going to find the number, the easiest number that will keep the x squared. And just like with the x over here, the easiest way to keep an x is to put a 1 in front of it. So that's what we're going to do here. Now, these other variables just complicate things. Okay? And what I mean by complicate, it's going to shift it right and left, move it up and down, and make it wider and skinnier. So, because we want the parent, we're going to get rid of these. And the way we do that is we're going to make b 0, because 0 times x is going to wipe out that x, and then we make c equal to 0. So if you look at standard form right here, we have y equals 1x squared plus 0x plus 0. And you can see that if I clean that up, I don't have to write anything that has zeros in it. It's a waste of time. Don't have to write a 1 in front of the x squared. That's how I get the parent. So your activity is going to ask you to look at the parent function, and then we're going to start tweaking it. So if you have your paper in front of you, your investigation is you're going to take a look at the parent function, okay, and you're going to fill in the values right here. And then, yes, I want you to actually take your ordered pairs, and I want you to graph it by hand, yes. Okay, you can look at it on the calculator, but I want you to transfer it to your grid. So the quick way of doing this is to just take a look at the first example here. Okay, remember the parent, this is the parent. Remember this is just y equals, so if you want to use your calculator, you can make your parent the first one, so you can say y1 is equal to x squared. And if you notice here, we have a different letter. What does that mean in function notation? A different letter means a different function. So, how did we tweak that? Well, it looks like there's a negative sign in front of that. So, you can go to your calculator, and go to the second line, different function, different line, and we can type in the opposite of x squared. Some people say negative squared. I'm old school. I say opposite of x squared. Winds up being the same. So, if you go, we already did this one over here, didn't we? So if I'm squaring a number, I'm multiplying it by itself. So this is negative 2 times negative 2. We got a positive 4. This is negative 1 times negative 1. This gave me a positive 1. 0 times 0 gives me 0. 1 times 1 gives me 1. 2 times 2 gives me 4. Okay? So if you graph these ordered pairs, remember this is an ordered pair, you got an input, you got an output, negative 2, 4. You come over here and you go negative 2 to the left, 4 up, put a dot. So eventually you should be have your parent over here on this grid. I'm not going to waste your time doing that. You saw it earlier in the video. So what you need to do is you need to take your calculator, go ahead down here and see what kind of outputs do you get when you punch this in. I want you to do investigation. So you have two functions, the parent and an offspring. So over here you should have two different looking parabolas, curves, smiley faces. These guys, okay? Now you're going to be investigating. I need for you to think, I want you to look, I want you to think about what happens to this guy. Does he shift left or right? Does he go up or down? Does he flip over and be reflected? Does he get wider? Does he get skinnier? Those are the things that this investigation is going to ask you to do. So, for this one, you have two functions. You should have two curves over here. On this next one, again, you have you start out with the parent. So yes, I want the parent back over here. And then you have two other guys, two other functions, because you have a function g and a function h. Just plug that in your calculator, get your ordered pairs, transfer it over here, and I want you to think about what's happening to the parent. Do the same thing down here. Okay, got the parent function, got an offspring, got another offspring. And then we'll talk about these questions down here, and we'll fill it in like we did with our lines. Remember with our lines we said it was steeper, flatter, or it translated up or down. We're going to use similar words down here. We're going to use shift right, shift left. We're going to translate up and down, and we're going to get wider and skinnier. So there's a lot of things happening here. Remember, there is back. Continue the investigation on the back. All right, again, this is really just y1 here, y2 here, y3 here. Put it in your calculator, take a look. Fill in the table values, and then transfer your graphs over here. If I have some map colors, it'd be preferable that you pick 3 different colors so that you can see the differences, and we'll talk about it more in class.